Hello and welcome to this discussion slash demonstration session for my latest project, which is an FM synthesizer. So, without further ado, let's move on to the first little bit of demonstration. So, if I just press a key, you can hear that brassy FM tone come in. So it's a work in progress at the moment, and there's no presets just yet. There will be, but so that's just the basic sound with everything on like the initialized default kind of bland state, as it were, and we'll move on to creating something a bit more interesting later on in this video. So it's not just FM. I mean, that's all that I have to demonstrate at the moment, but there will be a sequencer with it, which I'm looking forward to working on, and also some more instruments to complement it. So possibly a programmable sound generator, PSG, so we can get some like square wave tones going, or maybe a few samples, or maybe a Roland 808 like drum machine, emulation. Yeah, yeah. Vote for which one you prefer in the comments, I guess. Yeah, so I'm working on this bit of software, and I hope it will be out quite soon, or soonish. How long is soon? I don't know. As long as it takes, but like, I really want to like finish this project and get something out there. Yeah. I'm concentrating on the features that absolutely need to be added, but there's always like the creative like juices to add extra kind of interesting things. Just wanted to talk a little bit about like, why am I doing this? Like, what's all this about, basically? So I just love making things with like maths. So I've done stuff with visual art before, very much into that. And this project came about because I wanted to synchronize my animations to music, and although you can do like visualizations of MP3s and stuff like that, you don't really get like that precision to, I really wanted to like link things to like, exact notes and exact kind of, changes in the sound. And so MP3 is not very good for that, but if you have like the musical score, then obviously you do have all that information. And another issue or another source of inspiration that led me down the synthesis direction is that my visual art software like runs on the web, and on the web like you need a fast response time. Like, people want everything like now, even though like we do have fast connections, stuff still takes like some time to download. And basically whatever I worked on, like, I wanted it to like be the best. So if we were going to go down the route of creating a synthesizer or creating an instrument based on sampled sounds, so we could have musical score and then sounds for like each instrument, then I would want it to be like the best, which means like you need like a piece of recording for like every instrument that you're going to use, every note of that instrument that it can play, and different velocities as well, how hard like you strike the key or blow into the instrument. So that is an awful lot of sound recordings, and I was finding even just for one instrument, it was taking a few seconds to like download all the data, which yeah is not particularly long wait, but long enough that it kind of disrupted like the creative process of doing that linking the the, the visual art and the music. And yeah, so then I thought, like, why not like get into like synthesizers, because then all you need to transmit is like a bunch of numbers, basically like the positions of all like the knobs and sliders on the synthesizer and stuff, which is like a tiny amount of data to download, and it just like fitted in perfectly with like the retro vibe of my art. Perhaps I should demonstrate some of it. Let's briefly look at my visual art for a second. Yeah, so here's one example. So you can play around with, I don't know what to play around with, what would be best. Like most of it's been a while since I've touched this particular sketch. Oh, I know the triangle ones look interesting. Yeah. So yeah, let's change it to like that. And we can change some stuff with colors. Let's just do something quickly. Maybe make it go towards the blue end of the spectrum. Or I quite like making it at the red end of the spectrum. Anyway, we can mark like some animation points. I'm going to set that to be the end animation frame. And now if we play it, yeah, very detailed. Oh, that's quite a slow transition. We probably don't want 10 seconds. Anyway, you get the idea. Set that to like 3. I probably should have changed some more stuff. But yeah. So that's that. So getting back to music, yeah, my stuff's got quite an abstract vibe, strong geometric lines. It fits right in with kind of retros, 80s, 90s. That sketch I just showed you was actually based on a BBC Micro program. I mean, I've added more colors and more sophisticated options, but yeah, I could show you the original, but yeah, I don't have the page loaded up right now, and this video is about music. So, and I think FM synthesis is just the perfect kind of point in history where you've got the Sega Genesis, or the Mega Drive as it was known in Europe, and you've got the Creative Lab Sound Blaster card, for an early sound card for PC, and the kind of sounds that you can get out of these systems are they're kind of semi-realistic, like you can, with a bit of practice, generate stuff that kind of sounds like real instruments, much more than anything synthesized ever did before that point in time. So it's just way more realistic than like the 8-bit systems of kind of bleepy noises and stuff, which that's a fantastic kind of art form, working with really super lo-fi, really early like computer systems. But I love that as an art form as well, but it's not quite where I want it to be. Wanted to have, you know, bit kind of broader sound palette than that. Um, and yeah, what else have I meant? Yes, parameters. So another great thing about synthesis is that um, you've got all like these kind of knobs and adjustments that you can make. Um, so 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 yeah, you can like change the sound like in real time, which is not something that you can do with like a recording so easily. Um, and you can also read the values of the parameters back, so we can feed those into, as inputs to the visual art directly, which goes back to what I was saying in the beginning um, about formats like MP3 not being very useful for visualizations. Um, and so this slide's just a bit about kind of like my philosophy about like where I'm going with this. I think there's something about choosing like just the right level of complexity, because when I was learning about like synthesis like about 3 years ago, from YouTube tutorials, so we're going like full circle from like learning from YouTube to feeding back to YouTube. Well, I'm always still learning from YouTube, but yeah, I was finding that these days you can find great reviews about like new systems, and it'll be like they have like 10,000 oscillators and like 50 LFOs, and it's like, wow, like you can make like amazing sounds with all this stuff, but like you've got so many different components that like controlling all of that complexity and like taming it and like finding the bits that you actually want to kind of bring out to the front and uh, give prominence, to create the sound that you want to create from all the possibilities. I found quite overwhelming in a way, and when I looked at music software like DAWs, there was a similar kind of issue, difficulty in just kind of getting started and doing the basics, because there were just so many windows with so many different features, which is brilliant if like you're at that level of like professionalism. But like I just want like everyone to like be able to like make music, which brings us on to our next little bit of demo. So I didn't make this tune, well, Bach did, but someone inputted it. So this program is called ProTracker. It runs on a system called the Amiga computer from the 80s and 90s. This is an emulator. And yeah, this was my first exposure to like making like computer music as a kid. I unfortunately have lost all my original floppy disks with my own tunes. But yeah, so I'm just going to give it a quick play. So yeah, probably not the best tune, probably not well, Bach's amazing, but I mean the rendition. Probably not the best one to demonstrate this tracker. There are kind of better mods out there, as they're called. But it just demonstrates nicely, I think, that how like you can fit like the entire composition on a single page, which or a single kind of, well, not the entire composition, but everything that's kind of going on in that moment. Those few bars. So you've got 64 lines, which is 4 bars of music. And, it's quite a small amount to scroll up and down. And obviously this is a very low-res screen as well, and they're only using half of it. So this isn't the best user interface ever, but it's straightforward. You've got everything laid out. So this interface, this kind of style of interface, is called a tracker, which yeah, I think trackers are pretty cool. Although I also like the piano roll interface as well, which is more common on modern systems. So yeah, should probably try and incorporate a bit of both when I work on the interface for the sequencer, which for my own project, which the sequencer, some of it, some of the internal bit, kind of playback routines are already written from a previous project that didn't quite get finished. There's no user interface for it at the moment though. So yeah, that brings me on to my next point, which is about like cohesion and like trying to get your head around like how people kind of brought a, created a product in like the 80s and 90s. Like how did they like design these like physical synthesizers by companies like Yamaha, and how did they like choose like an appropriate like range of features from like all the possibilities that made sense, and kind of complemented each other in just the right ways. And in those days, cost would have been like a big limitation. You could only have like a certain amount of processing power and electronic components and stuff. But these days, that's relatively cheap, even in hardware, and certainly when you're implementing it in software. Like we've all got like super powerful CPUs, billions of times more powerful than like in the 80s. So it really comes down to like defining like the appropriate set of like boundaries and kind of limitations in a way, but like in a good way for yourself, I think. So so you can get like the expressiveness that you want, but without bringing like too much complexity that it becomes impenetrable, certainly for the beginner. And so yeah, when I first started to write my first synthesizer, which is not this current one but the previous one, I was at the same time learning the principles of synthesis, and so I was like watching a video and being like, "Oh yeah, that feature's amazing. Like I'm going to add that to my system," and it just ended up with like a bit of this, a bit of that, and it's just like a complete like uh, jumble of parts that didn't really connect very well. There was no cohesiveness there, so that's something that I'm quite kind of interested in. Yeah, boundaries in a good way, and that carries on to the last point in the slides, and then we get back to like the practical stuff, which is just to say something about the kind of interface between the musician and the instrument. So if you have like an acoustic instrument, like the player has like if they're a good player, they have like complete mastery of like how the sound is made, and they kind of know like all like almost like the kind of nooks and crannies of the instrument. Like they know like exactly how to manipulate it with their hands or their feet, or their mouth, to get like exactly the sound that they want, and they kind of know like the range of sounds that the instrument's capable of, and like so you can just kind of jump to getting it to do exactly what they want it to do. And so there's always this tension, I think, with software and electronic instruments, that like you always like want to add more features, because then more features is more powerful and like more creative potential. But I'm also kind of mindful of like I want like the user to just be able to like be at one with the instrument, and like be like, oh yeah, like it's almost perfect, but I just want to like change this bit, and like know exactly where to like zone in, and just exactly which parameters to change and by how much, to get it exactly where they want it, and just to be able to get there really really quickly. So the human computer interface is quite important, I think. So getting back to what I've actually created, which is like I say, very much a work in progress. So I'm going to give I'm going to jump into like tutorial mode now, and be like, so what is like this FM thing that I've been talking about all this time? So I'm just going to tweak a few things up here. So we're going to come back to what these diagrams mean in a second, but I'm just going to put it in the most basic one down here. And I'm going to turn off operators 2, 3, and 4. So now we've just got a single what's called an operator, which an operator is just a fancy word in FM synthesis terminology for an oscillator and an envelope. So an oscillator and an amplifier, basically, so we can control the volume of the oscillator. And we'll come on to envelopes in a minute. But what I'm also going to add in is down here we've got our low frequency oscillator. So we've got the 4 main ones, 4 operators, or is it 4? Or is it 8? We'll get back to that in a minute. But for the moment, consider that there's 4. And then we've got the low frequency oscillator, which is for making like your vibrato and tremolo and stuff like that. So it moves at a slower speed than the other oscillators. Yeah, so don't pay too much attention to like what this panel looks like, because a running theme throughout this like discussion is going to be the user interface isn't finished yet, and some of the bits that have been made need to be changed a bit and improved. So the low frequency oscillator does have more options, more stuff that you can do with it. The sound engine is much further on than the user interface, but it's kind of functional enough for present purposes, so let's get on with it. So at the moment, if I just play a note, a little bit quiet. I need to press the normalize button. And I might also just change the envelope. At the moment, the sound's coming in gradually. Let's make it come in immediately. That's better. So that's just our sine wave. Like there's something out there, not out there, in here, in the computer, that there's vibrating or simulating a vibration, very quickly, so that you can hear it as sound. But now we're going to add in a much slower vibration, which will it'll just shift the frequency of that other oscillator up and down a bit. So we've got one sine wave that's making the sound, and another sine wave that is just altering the frequency of the first one to make it like higher pitch and lower pitch, very slightly. So we've got that sound that's slowly wobbling backwards and forwards at 3.78 hertz apparently. And if I move that up to 9, so we can still hear the pitch going up and down, but now it's kind of sounding a bit different. It sounds less like vibrato and more like almost like a kind of gurgling, like kind of underwater sound. But you can still hear it kind of individually going up, down, up, down. But if I move it faster and faster, so if we go to 68.6 hertz, which is reaching possibly going on beyond what you might consider low frequency, but anyway, some low frequency oscillators let you do that. Then if I play a note now, then you can hear like it's got like that kind of let's move up an octave actually, just to make our sounds a bit louder. It's probably like super loud for you anyway. I already recorded one take of this, and when I played it back, the sound was all overloaded. The volume recording levels were too high. See, so you can tell this is my first YouTube video. We've had to do a second take. Yeah. So anyway, so now we've got like, we're not hearing it like as vibrato, but it's kind of like, it's a flavor kind of added on to the original oscillator. It's like a change in like timbre rather than vibrato. So that's basically all FM is moving the frequency of an oscillator up and down very fast using a different oscillator. So I'm going to turn all the LFO stuff off now, and we're just going to use the 4 main oscillators. So going back up to the top, we've got what's called algorithms, which is it doesn't mean the same as in like a computer programming algorithm. Well, it's kind of similar, but in a sense that you're programming the synthesizer by setting up how you want it to, but it's not computer programming. But they call it like algorithms. It's like the connections between the operators. So we're gonna select this one, algorithm 0. Yeah, so there will be more algorithms than this in the final product. This is just the ones that are already in there as presets at the moment. So here we've got oh well, first of all I'm going to turn off operator 1 because we don't need to make it sound that complicated just with this demo. So we've got operator 4, which is directly connected to the speaker. So that's the one that we hear as this. That's the oscillator that's actually making the sound for us, but it's being controlled by, it's having its frequency moved up and down by operator 3. So we call operator 4 the carrier, because that's the carriers are the ones that you hear, and the other ones are the modulators. So operator 3 is modulating the frequency of operator 4, but then operator 2 is also changing the frequency of operator 3. So you've got like a double thing going on. It's like almost like 2 pendulums joined together or something. And then down here we've got like the modulation matrix. So you can actually invent your own algorithms by writing things in this grid, basically. So it says exactly what I've just said. That like so operator 2 isn't sending anything to the speakers. Now there's operator 3, but operator 4 is sending amount of signal 99, which is full strength, to the speakers. And then operator 3 is manipulating frequency of operator 4, and again at the moment it's 99, so maximum strength that can possibly be. And then 2 is changing the frequency of 3. Yeah, I mean I could disable 2 at the moment here. And now we've just got 3 changing the frequency of 4. And that's what that sounds like, which if I take out operator 3 as well, just have 1, no frequency manipulation. And then obviously that's like really dramatic. So what we're, it's a completely different sound. And it's actually kind of distorted because it's at such a high level. So what we want to do is I'm going to move this down to level 73. So I've got a patch that I've made previously that we're going to recreate. I'm going to guide you through it. So now that's sounding a bit gentler, and we haven't got any envelopes yet. So So that's a big part of making the sound. You've basically got three things. You've got like the nature of your oscillators themselves, the signal, the shapes of the signals that they're making. You've got and the way that they're connected is the second component, and then the third component is the envelopes, like how their signals change over time. So at the moment, it's static. Like we're not changing the amplitude up and down with time, so the note starts immediately as I press the key, and as soon as I release the key, it stops. So there's no kind of control over, or very little control of the volume over time. We haven't got any envelope or again an instantaneous beginning and end envelope on the on operator 3 as well. So we haven't got. And what that would do is if we alter the parameters of the envelope on operator 3, because it's not connected to the speakers but it's connected to operator 4, it would change like how the timbre changes over time, which is quite important. So yeah, okay, let's move on to the page for operator 4. So here we've got the shape of the waveform that it makes. So at the moment it's a simple sine wave in quotes, but because we've got all these oscillators connected, you can actually do a surprisingly complicated amount of stuff just with sine waves, which is all we're going to do in this initial demonstration. But we have got all these other presets available here. In fact, more presets than this, but I ran out of room in the list, so we're going to have to make a different user interface that displays them in a much better way. And actually, an interesting thing about this FM synthesizer, which is different to some of the other FM synthesizers, is there's kind of two different ways of looking at this. So these more complicated wave shapes, you can either think of them as being like just one oscillator that is capable of creating a complicated shape, or you can think of it as so some of these are actually generated internally by having two different oscillators that kind of work like with or against each other to create more interesting shapes. So going back to these diagrams, like you could consider that there are 4 operators and they each produce, you can choose you can either consider that there's 4 operators with a rich selection of wave shapes for each one, or you can consider that another way of looking at it is that there's 8 operators with a smaller choice of wave types, but then obviously have 8 of them that can interact in more complicated ways. And we don't yet have the full range of controls available on the user interface, so we can only select presets. But that will come later. So you've got a kind of simplified, in quotes, it's still quite complicated. And then you've got like advanced mode, which is more flexible. A frequency multiple I'm going to come back to when we look at operator 3 in a minute. For the moment, just note that it's on 1. Right. What am I looking at here? Okay. Sorry, I'm just looking at a spreadsheet on my other screen that reminded me how to set these up for the sounds I'm creating. I mean, I'm just doing that because I want to do it like quickly, but you can have so much fun. I've had so much fun just playing around with them, and you'd be like, oh, like that's not quite right. I just adjust it a bit more, and you can zone in on the sound that you want, or sometimes you can just play around with it and be like, oh, that sounds a little bit like I don't know, a xylophone, and then like you can start tweaking in that direction, or you can just be like, oh, that's an interesting sound. I don't know what it is, but it's interesting. Um, yeah, so it's a whole lot of fun to play with, and it's just amazing when you think like this is just maths, it's just sine waves, and yet it makes stuff that sounds like musical instruments. I just find it fascinating. Um, anyway, so envelopes. We've got a little diagram here that just shows the various stages of the envelope. So we've got time going across the x-axis, and then this is amplitude. So the first thing we're going to change is going to change the rate scaling to 0. So what the rate scaling thing does is it compresses the x-axis. So it means that when you play the higher notes, it goes through these motions faster than it does for the low notes. So I want to turn that one off for this particular operator. And then we're going to change the attack. So I'm going to move it down to 26. Which is still pretty fast, but it's not instantaneous. Yeah, it's still so fast that you can only really kind of you can tell it more. You can't really sense like the amount of time that it's taking to become louder, but it is more like it's just a little bit less punchy. Kind of a little bit less energy. And now I'm going to untick this. Sorry, I'm going to tick this box down here. This is a free choice of rates. So there's various boxes all around the user interface that talk about like tick this to have like a free choice. So if you don't tick that, then it means that the sliders kind of move and snap into positions that match the Sega Genesis. So you're limited to like the range of options that were available on that system, which could be interesting if that's something that you want to make like a tune that mirrors that the old equipment completely. Well, I say completely, more or less completely. Like so, we've got like the same kind of the same parameter names available as on those old systems, the same range of numbers that you can give to each one. They make the same, they have the same effect, but it's not like an exact perfect reproduction in the sense that I'm not reproducing like the glitchiness of the old systems. Like the audio is a bit smoother. In particular, if you're familiar with technical audio terms, haven't emulated like the aliasing. So Sega Genesis, as I've said before, was a source of inspiration, as well as a sound blaster, and so I tried to make it so that the sound engine will support everything that those systems supported, and that was where I started out. But then I went down a whole rabbit hole of reading like manuals and stuff for a whole range of different 80s synthesizers, and so if you're familiar with like the Yamaha DX range, then I think what we're going to end up with is something slightly more powerful than the Genesis and the Sound Blaster, more similar to a DX11. But also with my own mix of special blend features. Anyway, back to envelopes. So I've ticked the magic box that says a free choice of rates, and So that now allows us to go to 26.5. Just make that tiny little extra tweak. And the other thing that we need to do for this envelope is move the release down to 9. Yeah. So I should say these are rates rather than times. So if I move the release rate down, it means that it happens slower, so it takes a longer amount of time. So now if we play a note. So one interesting thing that you'll notice is, so at the moment I'm just changing the envelope for operator 4, but operator 3 is still set, so this one's released immediately. So you'll get a very sudden change of timbre as this one stops and the other one carries on for a bit. So you'll get like the brassy sound, and then you just get a plain sine wave. For a little bit at the end. So if we turn this one down to 9, then we can contrast it a little bit. Anyway, so where was I? Yeah, that's us done for operator 4. One slight issue with FM is that you get like this kind of proliferation of parameters. So although like these pages are the same, so there's not any kind of extra complexity to learn. There's just a lot of them, and so yeah, we need to add some features to be able to kind of quickly copy stuff between pages and things like that, or edit multiple pages at the same time. So operator number 3, we're also going to have a sine wave, but I'm going to change the frequency multiple to 2, which means so operator 4, the frequency multiple is at 1. So whatever note I play on the keyboard, it will play like the note that you would expect to be like tuned to that key. So if I press like the C key, then you hear a C. I'm just going to turn up an octave. Well, we're getting quite high notes now. Maybe go back down a bit. I'll go back down now. So yeah, I suppose we could see the effect of that now. So that's the octave that I've got the keyboard set to. If I turn up the frequency on operator 4 to multiple 2, it shifts the sound of the whole instrument up an octave relative to the keyboard, which is not what we want. So we're just going to leave that on 1. We're going to set operator 3 to have its frequency on a multiple on 2. So operator 4 has a certain frequency and it's being moved up and down, and the rate at which it's being changed, which is vibrating that frequency up and down, is twice as fast as the actual note itself. So it's really changing frequency very fast. Cool. So I guess we could demo. So this is 1 to 1 and 2 to 1. And you can move this up and put it on like really high numbers and you get quite irritating sounds. Wasn't too bad. Okay, so what else do we need to change with operator 3? So I have frequency multiple 2, rate scaling we're leaving on 1 now, so this one, it will push these rates up a bit more automatically as you go up to higher notes. Now we want to set the attack to 18, so a little bit slower. Then leave the release on 15. which is still going to have that weird effect when we're releasing a sudden change in timbre, but we've still got operator 2 to come yet. So now we're getting like, yeah, we get operator 4 come in really quickly, and it's like a gentle tone, and then it's still quite quick, but there's a momentary kind of, I was going to say a second, but obviously it's a lot less than a second. There's some milliseconds where it's just kind of building up that pressure to that more intense FM tone, while that moment where operator 4 has reached its peak and operator 3 is still getting there because it's got a slower attack rate. So now we just need to finish off operator 2, which I turned off, so let's turn it back on. Enabled operator 2. So now what we need to set this to is so that operator 3 and operator 4, their frequencies go up and down depending on what note I press on the keyboard. But something else that you can do is to have one that's a fixed frequency. And I'm just going to, this user interface is going to change because it's not intuitive at all at the moment. It's terrible. But I'm going to put in the magic numbers, or it doesn't have to be exactly these, but roughly the magic numbers that I found out from past experimentation. So it's in a nice, quite a very low tone. Because we don't want to go like crazy, we just want to gently nudge the frequency of operator 3 up and down a little bit. The amount that we move it up and down, that's controlled by the modulation matrix, which at the moment is still set to 99. I need to fix that. So I discovered that 57 is the right amount there. I mean, you can alter all of these things to taste. This is just this is my little instrument design inside the instrument that I designed. So I designed the synthesizer, but then you have to make your own sounds within the synthesizer. So now it's only 57, which is still a reasonable amount, but so it's moving the frequency of operator 3 up and down quite a bit, but it's moving it up and down by quite a large amount in total, but it's not doing it like very fast. It's doing it kind of slowly up and down, like big swings, but slowly. Right, what else do we need to fill in? And like I say, this is fixed, so it just gives it, it's perhaps not very easy to tell, which is, yeah, you don't want it to go like too crazy. I mean, you can get some really interesting effects, but because it's not linked to the key that you press on the keyboard, it will kind of be in tune with the other operators when you press certain notes, and it'll be kind of out of tune for other ones. So it adds a bit of like dissonance, a bit of character in there. Right, what else do we need to add for this? Nothing. We're just going to leave it at maximum attack, instantaneous release. So yeah, that's our instrument made. So what I think that sounds a bit like is the recorder instruments that we had at primary school that made like really irritating high-pitched noises. So probably the bane of every like young mother's life. The kids making like irritating loud noises while they learn music. So we've recreated that in electronic form, which is pretty cool. Yeah, so let's just jam a little bit. Oops, I missed the key. I am typing it on the computer keyboard, and I'm not much of a keyboard player to begin with. It does support MIDI, so if I go to the Performance tab, yeah, you can launch MIDI from here. I don't have a keyboard plugged in at the moment, just because like it's a bit bulky and I'm like snug with my laptop. But yeah, you can play notes on the keyboard. You can make some adjustments to the parameters on the keyboard. There's still so you can actually edit the synthesizer not using the mouse but using like knobs on your keyboard, which is really cool. But that's still early stages. There's a lot more stuff to come when it comes to MIDI, but the basics are there already. Yeah, and something which is still yet to come. So, the moment you can play with the computer keyboard or the MIDI keyboard. There'll also be an on-screen keyboard for touchscreen devices. Yeah. So yeah, that's kind of yeah. I just wanted to talk in like the final section about yeah, just kind of like where I kind of see this going, and yeah, kind of what I hope to bring really, which is my own kind of unique blend of, like I said earlier, just choosing like exactly the right set of like synthesizer features, and it's going to be something that works on any device that has a web browser, basically. So desktop, tablets, phones. Yeah, so you just be able to like jam and create music on your phone, which is amazing, I think. Like when you're on the go. And as I said, the data that will be created when you create these instruments and when you create tunes with them, it's just going to be like a load of numbers, like really compact to store and transmit. So it'd be great for like using as like we'll have to have just a player routine for if you want to like embed it like in websites and games and stuff. And also kind of being connected to the web, it gives like and also running on mobile devices, it gives that opportunity to like be responsive and connected, networked and stuff. So something that I want to explore is the idea that the composer kind of sets out the kind of the world of the music, but then the listener can like navigate their way through that world and like manipulate, make manipulate it to a certain extent, kind of navigate different paths through the music by using the mobile devices and stuff. And the different people can listen to the same tune in different ways, and they can kind of interact with each other. And I guess finally some things to just sum up. So at the moment, the kind of working title name is it's the ModElation, which like really cheesy name. Like It's the best I could come up with. Like, I don't know. Suggest alternatives in the comments if you feel so desired. And yeah, there's definitely more to come. There's more in the sound engine to be brought out in a better user interface, more complete user interface. And yeah, there's some beginnings of a sequencer that's already been done. Yeah, there's various other bits and pieces. Except we're going to add more instruments, make it a complete like 80s ensemble. Yeah, I already mentioned yeah, I know, vote for your favorite one among like PSG samples and drum machine. Yeah, and yeah, so yeah, at the moment it's got a 6-note polyphony because that's what the Sega Genesis has. But I'm actually gonna increase it to 8, and we're also gonna have another little trick in that if you have a simple algorithm where you only need like two oscillators, then you'll be able to like split like one of the voices so that so you can play like so you can play one instrument with 2 oscillators and then another instrument with the other 2 oscillators that are available, or you can have one more complex instrument that has 4 oscillators. And as I mentioned before, when I say 2 and 4, they can actually, it could be 2 and 4, or each one of these can actually be 2. So we could actually be talking 4 and 8. But anyway, or any other combination. Yeah, and of course, you're not limited to 16 notes, all of the same instrument. Like you can have like different instruments on different channels. It's just 16 notes in total, plus whatever we add with the other aspects of the ensemble that we haven't yet created. Yeah, so yeah, I think there's a lot of creative potential there. Yeah, as you can see, if you search for like other stuff to do with like tracker music, yeah, even the humble Amiga with its 4 channels, you can get some interesting sounds going. Or some banging tunes, I should say. Yep. And there'll be a demo version and a paid version, I think. The demo will be pretty fully featured, but you know, yeah, basically everyone's going to make a living somehow, haven't they? So yeah, some features will be restricted to the paid version. It won't be too expensive because it's kind of entry level. Want it to be accessible to beginners in every way. And yeah, there'll probably be a Patreon or a Kickstarter as well with the usual kind of bonus features for people who make that little extra commitment up front. Yeah, and that's basically the end of this video. Like, thanks for sticking around. If you did stick around, well, obviously you did because you're still here, listening to me ramble on. Yeah, and I hope to come back with another video soon with an update with more features added, and yeah, it should be really cool. So yeah, thanks for watching the video, and I guess at this point I should ask you to do all the usual YouTube things like comment, subscribe, Please, please. It'd be amazing if you did. Um, uh, and, you know, you can have the kudos of commenting on my very first video. Yeah, thanks for sticking around, and see you again soon. Cheers for now. Goodbye.